Okay, so here I want us to discuss the exponents and surds, the exponential laws, and also the laws of surds, but specifically we want to first deal with the laws of exponents. Right, so here I included some revisions of the grade 10 exponential laws, as well as also the expectations in grade 11 that we are expected also to. So I will not dwell much on them. I'll just highlight and give practical situations where they are applicable, or examples where we are applying, they are being applied. Right, so you can just pause if you want to recap and just brainstorm yourself again on them. It's quite good to do that. Right, so again, some of the things we should get familiarize ourselves with. So these are also, for the sake of time and progresses, I want to go into exercise where we are applying them directly. Right. So before that, I just want to examples of these laws. We do have the law where we have x exponent of negative a, right? Hypothetically, just indicating it that way to say it says x exponent of a, right? What basically is happening is you have to know that whenever we have this negative at the exponent, to deal with that negative or to eliminate that negative in another way, we can say x exponent of negative a, it is the same as 1 over x exponent of a. By that, we mean having a situation 1 over 4. This negative is the one that has been replaced by this part. So be 1 over 16. So that's what the law is. It becomes 1 over 1 and the same as to just say, just write the value as it is. So it becomes 1 over 2 as it is. Right. So that's what is happening. That's the also 1 exponent of 2. The b through f is when the exponent is a fraction. What do we see, which means this denominator, it becomes the root sign, and the numerator becomes the exponent. So r over 2. The exponential law, this exponential law is telling me that it is the same as the square root of 4 exponent of 3. I just want it again to be on record to know that this is the same root of 4 exponent of, or to write this is practically one and the same thing, right? So we can now deal with it further from there. That's what we have. An 8, again, we are saying we have the cube root of 8. So the cube root of 8 squared. It's basically one and the same thing. That's what apply this law, and we see how do we apply it. Okay, the first question there is saying, write down the following without the root sign. So we have the fourth root of 6, right? So basically what are we doing? We are removing from the root form, from the set form that it is, to exponential form. So how do we do that? Following the idea that I was explaining there on the law, which is saying that whenever we are having a denominator which is a fraction, then the denominator becomes the root sign and the numerator becomes the exponent. So it's 6 over 5. This will give us 3 over 2. So that's what we have there. The cube root of x exponent of our exponent becomes the numerator, so we end up having x exponent of 5 over 3. It's now no longer in our, it's now without the root sign. The same applies with c, it is so over 2. Where is the 2 coming from? It is the square root sign. So we are saying the root sign is the exponent when it's now in exponential form. So it means d is now clearer in this. What does it over 4 in the same token? So it becomes much more clearer. Going again to e, it's saying the cube root of a exponent over 3, right? X exponent of 1 over 2. Where is the 1 coming from? Right. This is the same as x exponent of 1. So we are 4 exponent of 1 over 2. Basically, that's what it means. So, more clear idea. Right. The question now is a rotation. If I write b, so we are just changing now from the exponential form to the set form. So it means a, right, here is 1 and the same, right? So let's look at b. B is now saying, the b is saying x exponent of 4, the same as the 6th root of x exponent of 1, which is the same as the 6th root of x, right? So same applies with c square root of a exponent of 5. So it's clearer now. The denominator is the root sign, the numerator is the power. That's basically what you are to do. Same applies with the d. It becomes the cube root of, right? Same applies with e, it becomes the square root of a. Why? because the denominator is the root sign, as we have said, and the numerator becomes the power, which is the same as exponent of 1, so that's okay as it is. Then finally, the f, it's saying x exponent of 3 over 2, so that also becomes what? It becomes the square root of x exponent of 3. That's indicated here. We are saying it becomes x, the square root of x exponent of 3. That's f for us, right, to explain the question number 3. Right, so that's question 3. Right, the question 3 is saying simplify the following without the use of a calculator. Right, the first question is saying the cube root, that's 3a, is saying the, right. So how do we simplify that without the use of a calculator? First things first, simplify 8 to its simplest form raised to express it in exponential form to its simplest form. So it becomes the cube root of 2 exponent of 3, right? Exponent of 4. We have just dealt only with 8. So my advice is, when you have your calculator, you can just punch on them the factor, but to its factors, express it as product of its prime factors. You are going to get 2 exponent of 3. Basically, using that fact pattern for those who are using them, the easiest way of changing it, or just to know that 8 is the same as 2 exponent of what of 3. So once you have done that, now you refer to the law which is saying x exponent of a bracket to the power of 3 is the same. It means when we have an exponent in a bracket and another one outside, it means you have to multiply the two. This is a law that we are simply following. So with that in mind, it means we can just directly multiply this to give us what? A 12. So it means I have the cube root of 2 exponent of 12. I'll try to show all the steps or the procedure so that if you are following, you can easily note what is exactly happening. So we have cube root of 2 exponent of 12, which then 12 over 2 from the same, from over 3, sorry, from the same over 3. Why? Because the root sign is the denominator, mind you, and the numerator is what? The exponent is the numerator. So we have 3 over 12, of course, and that 3 over 12 is giving us a 4. Now we have, right, so 2 exponent of 4, of course, it will give us a 16. 3a, how we are simplifying it. Right, let's go quickly to question 3b, right? It's saying the 10th root of 32 exponent of 2. So the same criteria, the same idea we have brought in there on a B. It is the same that we are also going to apply. We are having 32. It becomes the 10th root of 2 exponent of 5 squared. Mind you, we are having, so 5 times 2, that's what, that will give us a 10. So we have the 10th root of 32, 2 exponent of 10. And that will give us, of course, 2 exponent of 10 over 10. I'm trying to show all the steps, step by step, so that we can see basically how we are dealing with this. So they are almost similar. We are doing the same thing. So it means only later it becomes the cube root of 3 exponent of 3. So the cube root of 3 exponent of 6, 3 times 2, right? Then 6 divided by 3 there, as simple as all that. So we end up having a 9. Now, explain it in 2 different ways, but still referring to one thing. First thing, we can first deal with the square root sign. Then we will now raise to the power of 3. Right, so basically as it is, right, 1 over 4 is to say the square root of 1 exponent of 3. It's basically one and the same thing. So we can first find the square root. So 1 raised to, we end up having the square root of 1 giving us 2 exponent of 3. But knowing that 1 exponent of 3 will always be 1, there's no need to actually to write that. So I can do that by first dealing with this root sign. Right. So by that 1 over 4. So what I can do is I can first simplify. I can first 1 to that's a 64. Right, I get this because I used it again on the first option. I'm now using it on the other option B in simplifying the same question. Right, this is a law that so it is the way. right? So it means therefore the square root of 64 will then give me an 8. However, it's necessary always to note that whenever you are dealing with this, let us not also for dealing with the square root, it's imperative that we also take that into cognizance. But however, it's good again to note is what will happen. So I just indicated, of course, without the plus or minus, then it is 1/8. Right, let me go commonly used this question here. Like I have the 1 into just simply do what we simply do is which means here we are having 1, it gives us over 1,000, right? Reduced to the lowest term over 8, right? Right, if it becomes a half. Of course, we can do that, or we can just simply punch on the calculator, though the instruction is saying without the use of a calculator. So it's somehow, there are some things that you can actually do that may not really necessarily result in you losing marks after having done it. But of course, you have to show all the way. So I'm saying first things first, convert this decimal to -2. This is what we now have. Right. So having done that, the next thing that you do is you now simplify. -2 all done. We have dealt with the negative. The negative is gone. So upon simply, we can now end up having, right? We can now end up having it is in is given as this. So if we simplify it further, it means it gets 1 over, right? 1 squared, of course, it's a 1 over 8 squared, that gives us a 64. 64, it will give us, size it so. I might just want to explain that part quickly to say that 1 over 4. It becomes, so I'm having 1, just 64 directly. I have 1 over 5. That's a 5. Right, so after iterating and having that 64 will now give me, that's a 4. The cube root of 64 is apparently a 4. That's what is happening there, right? We have arrived at our answer, but is that the only way we could have done it? Right, I just want to quickly show another way that we could have done it, though it's not a much more commonly used way. I just want us to just know that it's possible again. The way it is, we can simplify it that way. Okay. Let me show you here. Right. We are having the cube root to 5. 0.125, right? 0.125 exponent of negative. We can find the cube root of 0.125 without the use of a calculator. It's possible. What you simply do is, so I'm saying that the most commonly used is manage to simplify without the use of a calculator. I have 0.04. It becomes 0.2. How can I find it without using a calculator? 4, the square root of 4 is 2. Then I simply check the number of decimal places. Now, because I'm finding the square root, I just say, so 1 becomes the decimal places I must find on my answer, right? So even if I have the square root of 0.0004, these are 4 decimal places. It means my answer should have 2 decimals, the answer without using a calculator, right? How about if it's now a cube root? Instead of using the division, instead of dividing by 2, the way I was doing the square root, here you now divide by 3. 125, how many? 0.125, how many decimal places do I have? 3. I say 3 divided by 3, I get a 1. My answer should carry 1 decimal place. So it means my answer is 0.5. What am I now focusing on? The cube root of 125. So the cube root of 125 is 5. So I end up having 0.5 exponent of -2. It's possible without using a calculator. So it's possible I can find that. It's a cheat code to try and just arrive at the answer without using a calculator. You can actually do that, and it's possible, right? So here is where I am now. Now, dealing with this, it means I can now say 1 over 0. Then from there, that we now say 0.5 exponent of 2. That will now give us 1 over 0.25. Using the same criteria in reverse. Now we are saying 0.5 squared. We are no longer finding the square root. Okay, one would want to ask to say, okay, what if, like in our case, by 3 without leaving a remainder? Then it means it can be done without a calculator. As long as it can be done without the use of a calculator, it means it must be exactly divisible by the root sign, the number of decimal places, like what I've just done here. Okay, so I'm having 0.5 squared. My answer is 0.25. How can I know the answer without, then I say number of decimal places. How many decimal places do I have? 1. So I must have 2 decimal places. So finding the square root of 0.25 without using a calculator, I was just reversing this idea that I'm bringing in right now. So I'm saying 0.5 squared can be calculated without the use of a calculator. It's giving me 1 over 0.25. Then at this point, it is where we now change 0. A common fraction, which is 25 over 100, which reduced to the lowest over 4. So 1 over 4 is the same as what? 4. We have arrived again. There are many ways of killing it. I want to go to F3F, right? It's saying simplify the square root of 4, the square root of the exponent of 4 over 3, right? The square root of 4 exponent of 3 the exponent of 4 over 3. Right, let's try to simplify that. First things first, we have this square. It is the same as 2x, but will now give us 4 over 3. Of course, multiplying 4 over 3, that's what we are having. So half times 4 over 3, that will give us 2 over 3. We have simplified, right? Of course, we need not go further than this, right? Let's go to G, right? In the same token, with the G now, the first thing that we do is we deal with the square root of 3. The square root of them is 3 exponent of half, 1 over 2, right? Bracket exponent of 3 times, now we have half times 3, that's 3 over 2 times 3 exponent of half, right? So this is where we are at, right? I'm looking at this one. 3 over 2, basically, right? So it means now at this point, we are simply adding now the exponents directly, bring back the base, 2 over 2 plus 1 over 2, that's 4 over 2. And 4 over 2 is the same as 2 consequent, that will end up giving us a 9. We have simplified it, right? That's G there. Looking at H, simplifying H, it's saying the fourth root of a exponent of the square root of a, right? First things first, we are going to remove it from the root side. We are going to remove the original form, right? So we have, let's start with this, the fourth root of a exponent of 2. It is the same as a exponent of 2 over 4, which apparently is the same as 1 over 2, times a, right? So I have a exponent of 1 over 2 times a exponent of 1 over 2. That's what we now have. Then 1 over 2 plus 1 is the same as a, which means we have dealt with this, right? Idea. H is saying a exponent of 1 over 4 times x, x exponent of 1 over 4 times x exponent of 3 over 2 times 2. First things first, we will simplify specifically this part. So right, times, right, 3 over 8 times 2. Multiplying 3 over 8 times 2, we end up having 3 over 4. So we have x exponent of 3 over 4. We've simplified 3 over 8. So what does that give us? It's going to give us x exponent of 1 over 4 plus 3 over 4. So adding this is x. That's basically what is happening there. Right. Looking at the last one, which is now saying the square root of 8, x does that give us? Right. It's going to give us, right, starting with the 8. 8 is the same as 2 exponent of 3, borrowing from the idea we were using on A, B, and C there. So that's x exponent of 6 bracket x exponent of 4. Right. The next thing is to begin to multiply the exponents. That's a 12. 6 times 4, that's a 24. So this is what we now have. Then from there, the square root, remember, is the denominator of 15 another way. I'm trying to show all the steps that we can follow. 1 over 2, right? It is the same thing, which means it's the same. It's not that much necessary. What is important mostly is to know that the denominator becomes the root side. We end up having 2 exponent of 12 over 2 times x exponent of 24 over 2, right? So 12 over 2, 24 over 2, that's a 12 there, right? So this is what we end up having. But from there, 6, right, that can give us a 64, right? X exponent of 12. So we have simplified it. That's as far as it can go, and it is marking our last question. So I've tried to explain these questions to say this is how we can simplify them using the exponential laws, specifically focusing on the exponential laws in this lesson or in this video, right?